Okay, so for the third and final demo, this is around Azure Sphere DevX, and I just want to explain to you a bit about what I've done with that. So we've got an Azure Sphere DevX application here that we're building inside Linux POSIX. It's our POSIX C application. It's going to be calling upon the RemoteX library for remote peripheral access. I've ported across the Azure Sphere DevX library to desktop. It's called DesktopDevX. When I said ported, it's extremely modest, mostly because, of course, all the peripheral APIs are being supported by RemoteX library, so there's no changes to those. I had to make a very modest change to the way authentication happens with Azure IoT Hub. The other library I'm using is the Azure IoT SDK for C. And the final library I'm using is this thing called UV, which is a cross-platform event loop library. So this application is going to be running an event loop. And the rest is pretty much as you'd expect. Alrighty, so what we're going to do is bring up, this is an Azure Sphere DevX application. So appreciating the whole kind of idea behind Azure Sphere DevX is to provide clear separation between kind of what I call infrastructure code versus the code the end or the developer is writing for the solution. So the code that the developer cares about. And the whole idea behind this is very declarative. We've got bindings for a GPIO, we've got bindings for timers. So these timers are going to be used to feed the event loop. And we've got bindings in there for device twins, direct methods, and pulse width and I2C. So I'm going to launch the application. Actually, no, before I do that, I'm just going to talk a bit about the hardware setup I've got. So I've changed the hardware setup around a little bit, and I've got, in this case, a particulate matter sensor connected up to the Ethernet board, and I've got a EEPROM or EEPROM click connected on, so it's 256K EEPROM that I'm going to be using for data logging. And I've got a click, retro click board, which has got 16 buttons and 64 LEDs. And I'm going to be using the buttons on here as well. So the buttons and the LEDs on the board. By the way, so the device drivers I used for the particulate matter and for the EEPROM, I actually used and wrote using RemoteX development. So I actually wrote the drivers from the desktop using RemoteX, and it turns device driver development into a kind of a dream. It makes it so much easier and really takes away the frustration because you can iterate so much faster as you're building out the device drivers because you're doing this kind of hybrid desktop device development. Right, so what I'm going to do is I'm going to fire up the application. So we'll just clear out some of this junk on the screen. And I'm going to launch the application. So remember, this application is launching in the context of WSL on my Windows desktop. The first thing it's done here, it's found the onboard sensor, which is great. And I've now made a connection to IoT Hub. And what I'm going to do is I'm going to put a breakpoint over here in this timer callback handler called publish messenger. And we'll just put a breakpoint there that gets called every 4 seconds, so it shouldn't be too far away. Okay, so what's going on here is I'm doing a JSON serialize of the data. Then I'm going to send it up to IoT Hub. I'm going to write that out to the console. And I'm now going to write that serialized data into the EEPROM. Obviously, probably a bit more efficient way to doing that, but that'll do for the demo. And now I'm going to publish that data off to IoT Hub and then increment the message ID. And that's just now going to loop through. So if I bring up IoT Explorer, I'll just clear out events. You'll be able to see that the data is now streaming up to IoT Hub, and you can see it goes message ID 8, 9, etc. So you can see the data kind of flowing up through. I can come back to my application and we'll jump down to around about line 240-ish. Put a breakpoint in there. This is a breakpoint for a device twin update, and we'll come in through here and I'll set the device twin so I can basically set a target temperature. So you'll notice on the device at the moment, though you can't see the color of it, the user RGB LED is actually red, but I think you're probably just seeing it as white. What I'm going to do is change that to 40. So I'm going to set the target temperature for this app for 40, and that should call the breakpoint in my device twin, execute my device twin, and that will turn off that LED because the temperature is now below the target temperature. The other thing that's going on here is I'm also sampling the buttons every 100 milliseconds. So I go and press a button, you'll notice that this LED, the user LED will come on. So if I press that button, that comes on and it will stay on. There's a timer, 2-second timer to go and turn it off. So I'm monitoring that every 100 milliseconds. You can obviously see I'm updating the 8x8 LED panel here I think it's every 500 milliseconds. And I'm looking at the 16 buttons on here again every 100 milliseconds. So as you can see, if I go and press a button here, you'll see in the terminal window, button 13 was pressed. If I go and press button 16, magically that will just display, and you can see the buttons coming up here. So again, that whole mechanism for sampling peripherals all just works, and I'm doing that at a reasonable rate at 100 milliseconds. Alrighty, so that was the third and final demo. I hope it gives you a bit of an idea, just the possibilities of really improving developer productivity and really software quality, because it becomes so much easier for a developer to start looking at the application without getting completely frustrated with the time to go and deploy the application, to hit debug and things like that. I found the device driver development, again, a breeze, and I think it honestly improved the quality of the device drivers I wrote as well, partly because it's so much easier to iterate through what is going on. Anyway, let me know your comments.